Hello, and welcome to the LeTourneau University Robotics Lab. My name is Samuel Veague. I'm currently studying mechatronics engineering, and I'm a senior here at LeTourneau University. So unfortunately, if you do come here, I will have graduated by the time that you'll be in this room, and you'll be unable to meet me. This to my left is an ST Robotics parallel robot. It has 3 large motors that drive a single axis in the vertical direction and the horizontal direction in order to move this tool along a single axis at a time. A parallel robot has multiple motors that will move the tool or limb of a robot in a direction together, and this will reduce wear on the robot and also allow for a greater degree of control and various speeds for the different parts of the robot. To my right is an ST Robotics R12 robotic arm. This is not a parallel robot, but what that allows for is 6 axes of movement, 1 axis for each joint built into the robot. This is programmed using the 4th programming language, which I will show you in a second using the program I have on the computer. The 4th program was developed in 1968 for various applications, such as this robotic arm. The program that I'm running is one that I wrote when I took the class, where it picks up an object and moves it to a different position. This program, when we did it, was designed to pick up a marker and move it to another position. If you notice, the robot has to turn all the way around. This is due to something called a singularity in a robot's design. Unfortunately, the singularity for this robot makes it so it cannot just immediately turn from here to here. It needs to go all the way around. This also protects the internals and wires from getting twisted and squished. To my right is another R12 ST Robotics robotic arm with a built-in microcontroller and distance sensor. This is used specifically in a lab where we need to turn a power supply on and off and attach different wires to it without a human. That lab was demonstrating, and this robot demonstrate how robots can be used in various applications where it may be dangerous for a human to go, and you can protect someone by using a robot. Lastly, this is the 4th robot that we have in the Robotics Lab. It is a Universal Robotics UR3. It's being rather temperamental today, so hopefully it works with us. It has a similar number, I believe 6 motors as the R12, but what makes the UR3 special compared to the R12 is the type of motors it has. These motors are capable of sensing when they have to apply extra force to move the robotic arm to a position. And this allows it to detect collisions. So it will stop if it collides with something, and this can be very useful for the various programs that we write it. When I took the class, we had to write a program where it would detect dominoes, pick them up, and then move them over. For now, I will show the robot moving to a different position from the one that it is currently in. Come on. It is moving very slowly because I set the speed to 18% of its normal, just to keep it from moving too fast, because sometimes the robots can jerk. This robot is also substantially quieter than the R12 that we have over there. So that is all of the robots that are currently in the LeTourneau Robotics Lab. Thank you for your time and watching all the way through. I hope that you enjoy this video and it will influence your consideration for the robotics program at LeTourneau, which is currently the mechatronics concentration for the electrical and computer engineering degree. We get a lot of good experience programming with the robots, and we learn a lot about just the various problems that need to be overcome with them, and also how some people have worked with the problems to make a very unique solution that is easy to set up for factory workers, such as this universal robot. Thank you very much for watching, and I hope you have a wonderful rest of your day.